Hello everyone, welcome to Multisoft's Virtual Academy. This is the free live online webinar for PDMS, and here it has been organized for you all to make you aware how the live online sessions will happen with Multisoft Virtual Academy. We thank you all for your patience and we look forward for your participation in the sessions ahead. Thank you so much, and I hope you all will enjoy the PDMS Free Live Online Webinar with Multisoft Virtual Academy. Multisoft Virtual Academy has organized PDMS Live Online Webinar. Multisoft Virtual Academy excels in the domain of providing instructor-led live online training, which involves no more traveling and change in your busy schedules. You can upgrade your skills at ease with live, real-time training experience, wherein you get to interact with the trainer and resolve all your queries instantly. The knowledge sharing is direct and effective. This live online webinar is an initiative to introduce our learning pattern, which will be happening once you enroll in for the classes. In this free live webinar, there will be a live chat session wherein you will be able to connect with domain experts and get to know about the latest industry standards. This free webinar will expose you to the wide spectrum of development concepts, engineering, designs and drafting, business analytics, project management, and many more to explore. This is the PDMS typing and designing presentation, which is being taken by Mr. Vineet, who possesses more than 8 years of experience in training and software administration. His professional experience prepares him to be successful at his job. His foundation is a piping engineering with experience in two main areas that are closely related, that is, piping layout, piping engineering, leading a team of designers and responsible for detail engineering of various modules using 3D tools that include PDMS, reviewing and approving, vendor skids, model review with clients, interdepartmental coordination, etc. Software administration side worked as technical consultant in Aviva, having in-depth knowledge of all Aviva products, PDMS, Aviva diagrams, and Aviva engineering, etc., and providing project support for smooth execution of projects, providing consultation of team to administrators and users. To brief you all about the topic and agenda of the webinar, this will all include designing, that is Explorer and 3D view, new local view of selection, multiple draw list clipping planes, new Explorer, isolate two sites out of Explorer, design, including search function and Excel import, Excel engineering, search function including creating of Excel list import, Excel spreadsheet link documents to design member, equipment and pipe work, new equipment primitives from new equipment selection table, that is G-part selection, not prepared yet, that is CAT projector, auto router, onboard pipe assemblies, new modify pipe component board or specification form, new ASL application, create and modify platform, create and modify ladder, and build opening into platform, create and modify staircase, new Paragon application specification from component form with Excel import, new table world that includes nominal, row table, branch table, reducer table, and G-part concept. This was all about the topic and agenda which will be included in this live online webinar of PDMS with Multisoft Virtual Academy. I would now like to hand over the host panel to Mr. Vineet, who will now carry ahead this live online webinar for PDMS for you all. Just in case you have any queries after the session, You can drop an email at info@multisoftvirtualacademy.com, or you can call us at our 24/7 available numbers, that is +91 8130 666 or +91 8130 666 We anticipate to give you the best learning solution with Multisoft Virtual Academy. Enjoy the live online session.
Hi all, this side is Vineet and thanks Shivali. So today's webinar is about a software called PDMS, and in this webinar we will be demonstrating the capabilities of a 3D modeling plant design software, which is PDMS. I hope we would be able to communicate what this software is capable of by the end of this session, like how a structural and consistent approach is adopted while implementing this software, how the software should be used optimally to curtail errors and improve interdepartmental coordination across the disciplines. Now, PDMS is widely known as plant design management system across the world and industries. PDMS is capable of simulating a fully detailed, full-size model of all significant parts of a plant. Significant parts like piping, equipment, civil and structure, inline and offline instruments, etc. Now, this full-size model with all the significant parts of a plant becomes a single source of information and engineering data for all the sections and disciplines involved in the project. Now, PDMS is a database-driven software. Unlike all the other softwares which are file-based, PDMS saves all the data in a database type called Dabacon. This Dabacon type of database is exclusive to Aviva. No third-party database is used in PDMS, unlike other software. Now, data inside the PDMS database can be read only through Aviva applications like PDMS. And the data stored in these databases can be output through different channels like textual reports, like your MTOs, weight control reports, COG reports, etc. and 2D drawings and review models. Now all the 2D drawings extracted from PDMS are dynamically linked with 3D model. That is, any change in the 3D model will be automatically updated in the 2D drawing, which basically helps in change management. Now, as a software, because of the overall size and the huge projects, PDMS as a software is subdivided into a number of modules, and each module has its purpose. Like design module is for 3D modeling activities for all the disciplines. For this design module is subdivided into different applications. Now these applications can be switched on only after entering the design module. Now different applications in design module are pipework, which is for pipework modeling, wherein you can model all your pipes, flanges and other fittings, valves, etc. Next application is equipment, which is used for equipment modeling. Structure is used for structural modeling like beams and columns, stairs and ladders, and all the walls and floors, etc. The next module is draft. Draft is the module which is used for drawing extraction. Like you can extract a 2D drawing from the 3D model using this module. Next module is isodraft. Isodraft is used for isometric extraction, pipe isometric extraction. Administration module is used for project user control and other project housekeeping activities. Paragon is used for catalog and spec construction. Propcon and Lexicon are used for properties constructions and UDA constructions respectively. Now all these modules, design, draft, ISO draft, administration, all these modules, they have some databases associated with them. So whatever work we do in these modules will be saved in the respective databases. Like for design, the database type is DESI. For draft, the data is stored in a pad type database. For Paragon, the database type is Kata, and so on. So these databases are stored physically in a folder. In the PDMS project folder, these databases will be stored physically, and whatever work we do in PDMS will get saved in those databases in that folder. Now, number of these databases depends on the size of the project. The bigger the project, more will be the databases. And MDB is basically a collection of databases which is used to facilitate the work for performing actions. Now PDMS as a software is widely used in offshore industry, oil and gas industry, marine industry for shipbuilding, and power industry as well. Now, as informed in previous slides, PDMS is capable of simulating a multidiscipline 3D model with piping, equipment, civil structure, electrical instrumentation, and all other significant parts of the plant. Everything, all the significant parts of a plant can be modeled in PDMS using the design application. Now let us see few of the design applications. The first application is equipment design. This application is used for modeling all the kinds of plant equipment items at any level of detail. Now there are different ways in which an equipment can be modeled. First, the equipment can be imported from a third-party equipment software like CATIA Pro-E. There are interfaces using which we can import equipment modeled in those softwares into PDMS, thus saving the time and man hours in a project. If not, then equipments can be modeled within PDMS itself using an option called standard model equipments. And these standard equipments can be used to create equipments in PDMS. Standard equipments are basically predefined equipments with parametric dimensions. That is parametric dimensions as in user definable dimensions. And a user can choose a physically matching equipment and can change the dimensions accordingly, thus again saving the time of modeling and man hours. If there is no standard equipment defined, then equipment can also be modeled by using primitives like box and cylinders within PDMS by the user. Again, multiple representation of equipment items is also possible in PDMS, which can be used to show obstructions and the maintenance volumes, etc. So let us go to PDMS and see this equipment modeling application. Now this is PDMS design module interface. From here we can switch between the applications like equipment, pipework, cable tray, HVAC structure and all. So let's go to the equipment application. Now this is a parametric equipment, and if you click here you can see there are properties associated with this equipment, and a user can change the dimension. See, I have changed the length and the length of this equipment is increased. You can change all these dimensions which are predefined by the administrator. And this equipment is again customized and modified as per the requirement. Equipment can also be created using these primitives manually, wherein user has to create a box, a cylinder, or assemble the shapes to create a complete equipment, if equipment is not a predefined one by the administrator. Now there are many other features in this application, but one of the important tool is model editor. This model editor is a tool which can be used across all the disciplines in PDMS. Model editor is basically a positioning and modification tool which makes positioning items in PDMS relatively easy. Like if I want to place this equipment over this equipment, one option is I check the distances and move it manually. Another option is I use the model editor and move it like this. This can be also used to modify the nozzles. Like I want to modify the nozzle angle. Like this. So this is how easy equipment modeling in PDMS. Next application is steelwork design, wherein structure model can be built using beams and columns, referring to a catalog shape. Now, catalog shape is like all the catalogs like British Standard and American Standard for structural steel is inbuilt in PDMS, and user can refer those standards while modeling in PDMS, all those standards. So all the members placed in PDMS will be predefined from those catalogs only. Civil and architectural buildings can also be built using this application, the steelwork design. This application can also be used to create stairs and ladders. Like if I show you, these are the beams and columns. We can always check the standards here. So this is a British standard, and this section is placed using this standard. So all the beams and columns placed here are referring some of the industry standard. We can also create buildings with proper windows, doors, and other details. All the civil items can also be created like trenches, floors, and equipment skirts, foundations, and all these items. Now, once modeling is done, 2D detailed drawings can also be extracted from PDMS. We can also extract material reports like the MTO, structure length, weight of the structure used. We can also extract the center of gravity report from this model. But again, the quality of all these outputs like the drawings, the weight report, the center of gravity report depends on the quality of the input. Next application is piping. Now using PDMS, one can model all type of piping, fittings, inline instrument items, valves, etc. And the tool which is used for piping is highly interactive, and it is also possible to undo and redo the work once done. PDMS piping is a catalog driven tool. Like the components for placement in designs are facilitated through specifications, so there are no chances of errors. Like there is a catalog at the back end, like the NC catalog or British catalog or any other standard. Components from those catalogs are fed into a specification, and then those components can be referred into design. It is also very easy to do modifications in piping. Like pipe once modeled can easily be modified for bore, spec, and any other change. Once your modeling is done, it is very easy to extract piping GADs from the model. One can also extract the piping isometric. Piping GADs are again dynamically linked with the model, so any change in the model will be automatically reflected in the drawings. Again, you have to go to the pipework application. If I want to place a valve after this elbow, so you just have to select valve. A valve is placed here with connected gasket and the flanges automatically. Again, if you want to modify, you can always change the position of the valve. If you want to change the hand wheel orientation, you can always change the hand wheel orientation here. If you want to change the leg, it is very easy to do the modifications here, positional modifications here using the model editor. Model editor can also be used for routing and all. We can use this tool for pipe routing. Then again, let's say this pipe is already modeled and later this pipe specification or bore is changed. How easy it is to change in PDMS is you just have to go to pipe, component, bore and specification, and right click, modify specification. Just changing it to any other spec, A3B. Apply. The spec is already changed. See, earlier it was A150, now it is A3B. Right now the size is 250. I want to change the size also. Modify bore, and this is 150 I want. See, the size is again changed to 150. You can see the flanges then now smaller than the nozzle. So this is how easy it is to do piping and equipment modeling in PDMS. So is the structural modeling. Similarly, electrical and instrumentation items can be easily modeled in PDMS using respective application. One can model cable tray, JBs, cableways, and other E&I equipments. Again, these equipments, electrical and instrumentation equipments, will be parameterized. These can be placed in model for layout visualization and checking. We can also define the terminal connections on the equipments. Cable trays can be modeled. Again, volume reservation can be done using the cableways. Cable tray supports can be modeled here. Again, these cable trays are catalog driven and can be modified as per the project standard. Similarly, there is a very powerful tool in design for designing the HVAC and ducting. There is a feature of branch and system splitting. This is again catalog driven, and all the catalogs can be modified as per the project standard. HVAC sketches can be extracted once modeled. Integrity checking can be done for the alignments and proper connections and all. And again, we can define the complete HVAC route, similar to like piping and other modeling activities. As already discussed, that PDMS or any other 3D modeling software is catalog driven. That is, all the items that you place in 3D will be referring some of the catalog. So in PDMS, there is a separate module for catalog and spec design, which is Paragon. In PDMS, there are inbuilt catalog and specs, which is predefined by Aviva, like your NC, British standard, and all the main standards are already there. But still, as a company or as a user, these catalogs and specs can be modified project to project or can be project specific. This catalog can be defined for piping, for structure, for cable trays, for equipments, like you can create the parametric equipments and all, for piping supports. And then again, all these catalogs needs to be referred into a specification for them to be facilitated in design. Now, any item in design from a catalog can be facilitated only by using a specification. Now, why we need a specification? Basically, a catalog is a set of all the components in a standard, that is all the components and all the sizes. But in a real-time project, we do not need all the components and all the sizes from a standard. So specification is a filter which makes only required component and sizes available for selection in design module, which makes it easier for the user to select the components and to adopt a consistent approach in the project, so that users are bound to select the components only available in the specification. No user can go out of spec and select any of the component available in the standard. So this is like how we can have a consistent approach in the project for if multiple users are working. Now again, once your pipe is modeled, one can extract the piping isometric from the model. Now this isometric is automatically extracted and will give all the required information about the pipe. Now all the information what is required on the isometric can be customized project to project by the administrator. All the backing sheets, the descriptions, the material columns, how the items will be represented, symbols of valves and fittings, everything can be customized. Just select a type, utilities, type isometric. So that's an isometric. Then it is the descriptions, like the size of the pipe, the total length, how many flanges are there in this pipe, what is the quantity of fittings, flanges, gaskets, bolts, everything. Now everything can be customized here, like this information here, this is called the title block. Again, we can extract fully annotated and dimension 2D drawings from the 3D model. Now these 2D drawings are dynamically linked with 3D model. That is, any change in 3D model will be automatically updated in 2D drawing, thus making it easy to maintain revisions and keep track of changes. Like any change you do here in the model will be automatically reflected in the drawing. Like this is a drawing, isometric view of the model. Let us say this is the 2D drawing of the model that we have seen in the 3D. If I change the position of this pump in 3D model, it should be automatically, if this drawing is dynamically linked, so this should be automatically reflected here. I'll do a dimension here. Okay, now let's update this. Graphic update on. See, this pump is automatically updated as per the 3D model. So this is like the dynamic linkage between the drawing and the model. And this makes it easy to maintain the revision and keep tracks of the changes. Basically the change management. Now another form of deliverable other than drawing is the reports. Excel reports can be extracted from the model of the model items, like for the material takeoff, for piping, structural, or any other item in the model. We can also extract the weight reports for structure, like the one attached here, and the center of gravity reports as well. Now, after the modeling, the most important thing is data consistency. How the data will be consistent in a model. Now, same as the link between the 2D drawing and the 3D model, there is again a link between the catalog and the 3D model. So any change one do in the catalogs will be automatically updated in the 3D model. You need not to reselect or rebuild the item again. You do the changes in the catalog and that change will be automatically reflected in the 3D model. Why? Because PDMS is a data-centric software. That is, the data is centrally stored and is then referred in 3D model. So any change in the catalog or the data center from where the data is referred will be automatically updated in design and then in draft. So this is the link is like throughout from catalog to from the basic input like the catalog to the final output like the drawing. Everything will be updated automatically. Now, after the consistency, PDMS also takes care of the access control and security of the project. So the first level of control is the access by the username. Like you have to key in, every user is assigned with a username and password with which he has to log in PDMS. The next level is the claim management basically. Claim management is like the PDMS items are temporarily logged to provide exclusive user access while the task is being performed so that no other user can change the object. This is called multi-right access and first level of control. Like if one user is working on an object, the item will be claimed by that user and no other user will be able to modify that particular item until or unless the first user has done with the changes. The second level of control is discipline level of control. That is, which is controlled by the project admin. This control is based on user's role. That is, a piping user for piping discipline should be able to change the items within his discipline only. He should not be able to change the structural item or electrical item or any other discipline item. So this is called the second level of access. There's another thing called status management in PDMS, which is like status control, using which item statuses can be defined and then can be extracted and controlled in the model. Like this is the Paragon module. That is the valve category. See, this is a catalog. This is the valve category. This catalog, this fitting of the category is referred by a specification here. All the item types are here and it is referred here. And then using this specification, this item is modeled in design. We can again use the search facility in PDMS. Like I want to search all the valves in my project placed in my model. So you just have to type. See, all the valves are placed here. Now I want to check in which line these valves are placed. That is the line numbers, and these are the vals which are placed in my model. Similarly, I can search anything like this. This is called the search facility. It is very easy in PDMS to modify the items, to search the items, to create the items, like create the piping structure, modify the piping in structure. So on this note, basically, I would like to conclude this session and hand it over to Shivali.
Hello everyone. I hope the live online session, the webinar for PDMS went well for all of you and you all enjoyed it. I'll appreciate if you may provide us with your valuable suggestions and feedback. And just in case you have any inquiry related to the course or the upcoming sessions, you can always drop us an email at info@multisoftvirtualacademy.com, or you can call us on our 24/7 available numbers, that is +91 8130 66206 or +91 8130 66209. Just for your reference, I would like you all to understand that you all will be provided with the recorded session of this live online webinar, which was being conducted by Mr. Vineet. I hope you all enjoyed this session, and just in case you have any queries, any doubts, you can always come back to us on our email IDs and our mentioned mobile numbers. Thank you so very much. We wish to give you many more such sessions ahead and look forward for your participation in terms of training with Multisoft Virtual Academy. Thank you so much. Have a great day ahead.